Hi students, welcome to Math4U. Today we are going to discuss about irrational numbers. This is a topic from real numbers class 10. Let's get started. So before moving into irrational numbers, let's see what are rational numbers. So rational numbers are numbers of the form p by q, where p and q are integers. So p and q will be integers and q not equal to 0. This is very important, q not equal to 0. So you can see here some examples given 2 by 5, 0, 6 by 1, 8, etc. So the 0 can be written as 0 by 1, right? 8 can be written as 8 by 1. So this denominator, q means that is the denominator. Denominator should not be equal to 0. That means if 6 by 0 is given, is that a rational number? No, this is not a rational number. Okay, so now moving towards irrational numbers. This cannot be represented in the form of p by q, right? Example for this are pi 3.625, you can see here. So these are examples for irrational numbers. So what kind of decimal expansion can be irrational number? So irrational numbers are non-repeating or non-recurring, then non-terminating. Okay, non-terminating, non-repeating decimals are called irrational numbers. So let's move on to the main topic. So we have a theorem in this chapter. The theorem says let p be a prime number. If p divides a square, then p divides a, where a is a positive integer. So let's see an example. So here, can I take p as 2 as it is a prime number? Okay, I'm taking here a as 6. So the theorem says if p divides a square, what is a square here? 36. So if p can divide 36, let's see, 36 divided by 2 is equal to 18. Yes, it can divide 36. That means p can divide a square. Then p divides a. So if p can divide a square, p can divide also a. That means a is what? 6. 6 by 2 is equal to 3. This is what the theorem says. If p can divide, if here p can divide a square, this p can also divide a. This is the theorem. So let's see how can we apply this theorem in solving problems in this chapter. Prove that 3 root 2 is irrational. So for proving 3 root 2 as an irrational number, first what we do is we will assume 3 root 2 as a rational number. So if 3 root 2 is a rational number, can we represent this 3 root 2 in the form of a by b, where a and b are integers and both the numbers are co-prime and b should not be equal to 0. What does this co-prime means? Co-prime means there will be only one common factor. So what will be the HCF of two co-prime numbers? 1. Clear? So this 3 root 2 is equal to a by b. So how can we write as root 2 is equal to, we are keeping the root 2 on the LHS and taking all the numbers towards the right hand side. That means here you can see that this root 2 is multiplied with 3. So this 3 will go to the other side. It will be in the denominator. Clear? So root 2 is equal to now a by 3b. So here you can see that a, 3, b all are integers, right? Integers, and here b not equal to 0. So can we conclude that this right hand side a by 3b is a rational number, right? That is a rational number. So if a by 3b is a rational number, can we say this root 2 is a rational number? Therefore, we are concluding that root 2 is a rational number. Okay. So this contradicts the fact that root 2 is irrational. This contradicts to the fact that root 2 is irrational. So what we can conclude here? We can conclude that our assumption that 3 root 2 is rational is wrong. Therefore, our assumption was wrong. And what we can conclude, hence 3 root 2 is what kind of number? 3 root 2 is irrational. Is that clear to you? Okay, let's see the next question. Proof that 3 plus 2 root 5 is irrational. Here also the same procedure we will start with. We will assume first this as a rational number. So let's start. Here I will write assume 3 plus 2 root 5 as a rational number. So as I told before, if this is a rational number, can we represent in terms of a by b? Yes. So 3 plus 2 root 5, I'm writing this is equal to a by b. As usual, a and b are integers and coprime. Okay. B should not be equal to 0 also. Okay. So now we are going with the same rule. We will keep the root number alone on the left hand side and we will keep everything others on the right hand side. So first I am writing 2 root 5 is equal to a by b minus 3. Okay. And we have to take the LCM on the right hand side. That is 2 root 5 is equal to a by 3b divided by b. Right. So now I'm going to write what is root 5. That means I'm keeping the root 5 alone on the left hand side, taking 2 also to the right hand side. So as I told before, this is multiplied. It moves after the equal sign. It will go where? To the denominator. So a minus 3b by 2b. So now if we are seeing the right hand side, you can see that there are a, b, 3 is there, 2 is there. All are what type of numbers? All are integers. So can we say that now this is a rational number? That means a minus 3b by 2b is a rational number, right? So therefore, can I write root 5 is a rational number? And what can we conclude here? This contradicts the fact that 3 plus 2 root 5 is a rational number, right? So how this came into like this? That means we have found out. So therefore our assumption was wrong, and hence we can say 3 plus 2 root 5 is irrational. Is that clear? So this is how, if one you have learned, you can do different questions. Okay. So let's see this one. If p, q are prime positive numbers, prove that root p plus root q is an irrational number. The same procedure we are doing. We are assuming that this is a rational number. We are assuming this is a rational number. So can we write it as root p plus root q is equal to a by b? Yes. Where a and b are integers and b should not be equal to 0. So now I'm going to shift everything to the right hand side except root. So here I'm keeping root p here and taking that root q on the other side. So it will be like a by b minus root q. This turns to other side, that will sign will be changed, right? So now we are going to squaring both sides. That means root p the whole square is equal to a by b minus root q the whole square. Okay, so can we write this of the form a minus b the whole square? What is a minus b the whole square? A square minus 2ab plus b square. Exactly. So now we are going to write, instead of this a minus b minus root q the whole square, we will apply this identity, right? So left hand side, root p the whole square will become what? P, that is equal to a by b the whole square, right? A square minus 2 into a is a by b is root q, plus root q the whole square. Root q the whole square is what? Q. Root of a number, when it is squaring, the root will go, right? Q. So now what we can do as next step, we are going to take the root number one side and everything else on the other side. That means I'm going to take this to the left hand side. That the negative will become positive. So 2a, then 2a by b, then root q is there, is equal to, you will get it as this a square, a by b the whole square, that is a square by b square. Then what you will get, we have here leftover plus q, then we have this p, then goes to the right hand side, it will become minus p. Okay, so now what we can do on the right hand side, now you can apply LCM here. That means the left hand side is 2a by b root q is equal to, you can see here, a square plus b square q minus b square p the whole divided by what? Yes, b square will come, right? So once you got this, you can do one more thing. We can take this also to the right hand side. So how can we do that? So let me write. So if I'm taking everything towards the right hand side, the left hand side will become q, root q ln, root q ln. So already what we have here is a square plus b square q minus b square p the whole divided by, what is there? B square is there, this part. Along with that, we are taking this to the right hand side. The denominator will go to the, where it will go? The denominator will go exactly numerator. So multiplied with the b, then 2a will go where? To the denominator, 2a into, because here it is in the numerator 2a, so after the equal sign it will go to the denominator. Here b is in the denominator, so after the equal sign it will go to the numerator. That is why it is written like that. So can we cancel this b square, and here one b is there, right? So what will be the next step? What can we do as a next step? Let's see. So this is equal to a square plus, here from these two, can we take the b square as common? Yes, b square into q minus p the whole divided by 2ab. So the right hand side is a square plus b square inside the bracket q minus p the whole divided by 2a, and the left hand side you got it as a root 9. Okay, sorry. And now the right hand side you got it as a square plus b square multiplied with q minus p, and the denominator is 2ab, right? The left hand side you got it as a root q. Okay, so now can we say that all this a, b, p, q, 2 all are integers? So right hand side is a rational number, right? So can we say left hand side is also a rational number? And how can we conclude? Therefore root q is also rational. This contradicts the fact that what? Root q is an irrational number. So is that our assumption correct? No, our assumption was wrong, and therefore we can say that root p plus root q is an irrational number. The last part is same for everything, so you can write by yourself. That should be crisp and clear. Okay, so let's see the next question. So let's see next question. Prove that root 5 is irrational. So for proving this irrational, we have to assume this root 5 as a rational number first, right? Therefore, we can take two integers a and b. So, integers a and b are integers, b should not be equal to 0, such that we can write root 5 is equal to a by b. Assume a and b are co-prime. Okay, so we can write a is equal to root 5b, just cross multiply this, and therefore what can we write? A square is equal to 5b square. How this become 5? Root 5 the whole square is 5. Therefore, now we can apply the theorem over there. What was the theorem you have learned related to this? I told in the beginning. We have to apply that, right? So the theorem is, let p be a prime number and a be a positive integer, and therefore if p divides a square, then p can also divide a, right? Therefore, we can say here a square is divisible by 5, and it can be said that a can also be divisible by what? 5. Right. Now we are considering like a is equal to, let a is equal to 5k. So wherever a is there, we are going to substitute it as 5k in this. So this will be turning as 5k the whole square is equal to 5b square. That means 25k square is equal to 5b square, right? So can I write that b square is equal to 5k square? Yes. So here you can see that 5k square, this you look into this, 5k square is equal to 5b square. This means that b square is divisible by 5. Therefore, can we say that b is also divisible by 5? Yes. And when you have done this expansion, you got this one, right? Cancellation, and then you got b square is equal to 5k square. This implies that a and b have 5 as a common factor. 5 as a common factor, right? And this is a contradiction to the fact, that a and b are co-prime. Okay, and root 5 cannot be expressed as form p by q, and this happened because of our wrong assumption, and we can conclude that root 5 is a irrational number. Is that clear? It is so simple. First we will consider it in the form of a by b, then assume that a and b are co-prime, and later we will come to the conclusion that a and b are having a common factor. What was the common factor which was having? 5 is a common factor. So contradiction to the fact that a and b are co-prime, and this reaches the conclusion that our assumption was wrong. Okay, and therefore we can prove that root 5 is a rational number. Is that clear? So now prove that 1 by root 2 is irrational. So let's see how can we prove this 1 by root 2 as an irrational number. First we will assume the same 1 by root 2 as a rational number, same like how we have done the previous. So assume 1 by root 2 as a rational number. So we will write it in the form of a by b. A and b are integers, b not equal to 0, and co-prime. Okay. So now 1 by root 2, I wrote here, this is equal to a by b. So now can we write root 2 is equal to b by a? Yes. Here you can see right side b and a are integers, and this is a rational number, right? So if that is a rational number, can we say that root 2 is also a rational number? This contradicts to the fact that root 2 is irrational. Therefore, our assumption was what? Wrong. Therefore, our assumption was wrong, and we can conclude that 1 by root 2 is irrational. I hope it is very clear to you. Thank you.